Awesome. Thank you, Billy. That was really, really nice. It's pretty amazing to be here in Oxford with you all. I'm super excited to tell you about my story. I want to talk about my love for hard problems, and I want to talk about what it means to be open to possibility and how that's been expressed throughout my life. Starting with me, I'm Canadian, yes, from Calgary. A couple of stories from my childhood. I was just thinking about when I was like, a story that my mother told me about being really small, and I annoyed her by solving the kids' jigsaw puzzles too fast. So she decided to mix them all together so I would be solving 5 or 6 at once, which I think is actually going to be great for Nillion. As well, growing up, I was like a big reader because I always loved stories, and I always loved reading big, challenging books. This love of hard problems led me into engineering, and after a common first year at the University of Calgary, which specialization did I pick? Well, the hardest one, electrical and computer engineering. As I got into it, I loved advanced calculus, I loved geometry, I loved like everything about the mathematics, which got me into microwave engineering, and that's what I studied in my master's degree. But of course, to make it even harder, I decided to focus on focus on the FTTD algorithm, which was a brute force implementation of Maxwell's equations within computers. So I got to learn all sorts of things within that area, which led me to Accelaware, which was my first startup job out of school. I wasn't exactly like first of anything there, but I did learn a lot. We were implementing this FTTD algorithm on GPUs, and I think we had one of the world's first commercially available GPU computing products in like the 2000s, which was very, very cool. In summary, when I play my video games, I always turn the difficulty slider up to high, which is funny. One other thing to note, because it's important to this story, I think going to Burning Man when I was like 22, a long time ago, it was obviously a lot of fun, but it opened my mind to like the universe of possibilities and creativity. I think putting all these things together, I think complexity and possibility is just the ultimate space for creativity. Fast forward, big jump for me in 2010. I moved from Calgary down to San Francisco. That was our very first office. Don't believe the Showtime TV series. That's me and Ryan Graves. Garrett took this photo. I knew Garrett back in college. He had launched StumbleUpon while we were roommates together, and I saw him move to San Francisco and sell at eBay, even though I was busy at home working on math problems that I thought were more interesting. That definitely was another indicator of what was possible. So when he asked me to come help build Uber Cab, as it was called in that time, I jumped at the opportunity. When I got to San Francisco, I had no experience working with a database, but I did know how to write code. I learned everything the hard way, by making mistakes. Initially, I worked on the sign-up flows, the product integration, taking all the parts of the prototype together to make it work. I launched the system into production and built like many of the core functions of like our Python business API. The technical achievement I'm actually really most proud of was, I think in the second month there, rewriting the dispatch algorithm, so how we were matching people looking for a car with drivers that were available. I think that algorithm stayed around for 5, 6, 7 years, my entire time at the company, which is pretty amazing, and I'm pretty stoked about it. This is a really hard problem when you think about it, like 2 people in different places being coordinated within 15 seconds. I think we're so used to having like mobile phones in our pocket that do this amazing stuff that we never really step back and realize how freaking amazing that is, that we can even just do that. Uber was such an amazing place. There's so many like good personal stories, good company stories. I remember the company decided strategically we wanted to launch in Paris, go international. So we had to internationalize the product in 3 weeks. I think there wasn't a single engineer on the team that believed it was possible, but we did it. It was pretty tough, and when we did launch it, it did have its problems, but we made it happen. We did some really smart things. One of my favorite things to tell people at Uber is our launch strategy. We have these incredibly smart, incredibly hungry, incredibly hardworking operations people in every single city, and we wanted to take advantage of their creativity in their own markets and their knowledge of what was going on. So instead of our engineering team building a centralized platform and pushing out how we wanted it to work everywhere, Instead, we built tools. And these tools would allow these teams to basically change all sorts of things within the app, from the fares to the routing, to the pickup zones that were available, to the car types. Even the cars that were moving on the map, they could change those for promotions and all sorts of things. This led to some funny stories, of course. Mariachi bands on demand for Cinco de Mayo was pretty hilarious, but the one that I will always remember was a partnership with the SPCA that was done in just Seattle, and I think they got a couple other cities to do it, where it was kittens on demand. Your fare went to the SPCA as a donation, and a qualified driver would show up with, a car full of kittens into your office or your house, and then at the end of the day, they hope to have them all adopted. They launched it on a Wednesday. We were just chilling, and we weren't really prepared like we were for Friday or Saturday or New Year's or Halloween or these other big times. And I remember middle of the morning, lunchtime, server meltdown. I've never seen so many requests on the Uber system. It was amazing. We also did some really amazing or really insane things. I remember when we transitioned our backend database on our business API from MySQL to Postgres. We did this because we were a geo company. We had tons of geo data. Postgres had geo query capabilities within the database, so obviously it made sense. I remember working super hard until 8 in the morning the first time we tried to do it, and then basically we decided to fall back because it wasn't looking very good. 2 weeks later, we tried again. We got it done. It was great. But guess what? The performance of these systems is completely different. I think it was 6 months later, or maybe a year later, we ended up switching back to MySQL. So that's pretty insane. Halloween and New Year's Eve were always totally nuts. We were always, everybody else was out having fun and enjoying themselves, and we were always a few trips away from total disaster. One of the biggest ones I can remember was, it was quite a large city. The dispatch system was still running, but the serialization to disk had basically failed 40 minutes earlier. And at a certain point, it got rebooted. Basically, the state of the system went back in time, by 40 minutes. Completely screwed things up. It was chaos. It was crazy, but thankfully, it was only, in that one city. My tenure at Uber was basically all about giving things away, because at a certain point I was involved with every single system. As we were scaling, I basically just had to find and hire new people and basically give them parts of the projects that I was dealing with. But because I was there so long, the actual trip creation process was something that I owned for probably far too long. Until finally, I think it was year 3 at the company, I had started into a management role at that point. It was a late night, a bunch of trips had been messed up, they needed to be created. I made a mistake, 2,000 trips gone, boom. Thankfully I was able to recover all the drivers involved, so they got paid, but there were 2,000 people that got a free trip on that day. I don't know if this was a mistake, because very shortly thereafter, they found somebody else in the company to take over this thing for me so I could focus on my management duties. In my management role, I moved into managing our analytics infrastructure, which is just the beginning of the Uber big data story. I got to learn about HDFS, MapReduce, what it meant to build a real-time metric system, all very complex things. My background is not very analytical. However, understanding the fundamentals of how computers work meant that I was actually able to really help mentor and grow the team in a good way. Finally after that, I went to Amsterdam, where I live today, and there I got to build a remote product and design team. So it was the first time I was actually directly working with designers, product managers. The biggest challenge there was it was a management one. We were remote, and the team was being fed not such great products to work on. I was able to use my political capital to pull a mobile payments project over to Amsterdam, and it's been a huge success, not just for Uber the company, but for the team there. So by the time I left in 2016, I couldn't be happier that I left, and did well by them. I can't say it enough, but Uber was really incredible. The people were so amazing, which is just like Nillion I'm experiencing so far. It also was easy to describe the product to your grandparents or your parents, which is completely not like Nillion, I can tell. Eventually Uber IPO'd in 2019. So I was there 6 years, and in those 6 years, we went from 2 employees to over 7,000, and we changed the world. It was freaking amazing. You know, my journey there was pretty much the wildest Uber ride you can imagine. You know, the truth is, success is a really long and it's a really hard journey. So, but yeah, what did I do post Uber? Well, yeah, I was definitely very burnt out. You know, we'd been working really hard. I was on call for a couple of years. So I focused on skiing, I focused on living, I focused on being healthy, focused on learning. After having some financial success, I focused on finding my footing and building my atlas in this like new world of experience and relationships, you know, dealing with new things that are both amazing and hard. You know, I invested in some cool companies. I sit on the board of like one of my favorite companies from Canada, PK Sound. They build robotic loudspeakers. I love it, it's amazing. In 2017, I went to Burning Man for the first time again in quite a long time. And lo and behold, I found myself in an RV with this guy named Andrew Masanto. Yeah, that's where I met him. That's where we celebrate our friendiversary, actually. It's kind of great. While we were there, we got into nerding out, of course, and he showed me this paper that he was looking at with this gossip protocol, sort of a new sort of consensus mechanism. And yeah, we were the guys nerding out in the dust about this like white paper, which is pretty hilarious. But I could see the possibility in what that paper represented by being able to have this distributed ledger paradigm, but without the need for a full history in order to determine the future. I thought it was great, but I wasn't in the right stage of my life to work with him on it, but he went and turned that paper into Hedera Hashgraph, which is pretty amazing. You know, after 4 years of skiing, last couple of years, I'm so lucky I was able to throw a birthday party for my 42nd birthday that was Hitchhiker's Guide to the Galaxy themed for all of my friends, even friends from childhood. I wanted to pay them all back for, you know, the lucky life I've lived. And once that passion project was done, I was kind of wondering what was next. Knowing that Andrew and I shared a discerning eye for projects, I asked him, you know, what he was looking at these days. And lo and behold, I was speaking to Miguel about this algorithm he had come up with called NMC. I started kicking the tires with the team. Now here I am at Oxford talking to you guys. So that's my story. But now I'd like to talk about Web3. So, you know, first of all, what are we talking about when we talk about Web3? I think it's a pretty loaded term. There's a lot of different ways to look at it. You know, the first one is big tech players bad, you know, small tech players good. I think there's something to this, but I don't think this is fully, you know, what we mean when we talk about Web3. The meme economy, there's definitely something to that. It's fun. You know, people are creating like really interesting stuff, and they're moving markets because of it. You know, maybe there's something to that being also Web3. As well, there's like the product definition side. Well, you know, you own your own data, and all the service providers you work with get to use that data on your terms. There's definitely something to that. But I think like the story of Web3 is a technological one, and it's one that I'd like to sort of quickly tell now. These are the good old days of like Web 1.0, the late 90s, when I first went to NHL.com to see like, I think that was the first website I went to go see like hockey scores or something, back in Canada, of course. So back then, the browser, all the interaction happened on the browser, and you would send things to the server, and the server would recreate the entire page every single time you had an interaction. Web forms still work like this. Web 2.0, code moved off the server and onto the browser. This was asynchronous JavaScript and XML. So now all of a sudden, the back end, where the data is, could become much simpler. So now your back end just became a repository of data from a number of different sources. So it was much easier to scale, and that's part of and then on the front end side, it was much easier to build a composable interface from multiple sources of data. You know, some would say that this architecture is what enabled social media to become what it is. I think that's probably true, even though, you know, there's no reason why those types of companies couldn't get built in sort of the Web 1 paradigm. So, but continuing on this progression with our water level going down, so what is Web 3? Maybe it's code and data are off the server completely. So now you have the data on your computer, you have the code that runs it, and you have the interaction. Maybe I'm old enough that I can make the joke that this seems like how software was in the 1980s, but now at least, it seems like the software we had in the 1980s, but we've gotten rid of like all the benefits of the cloud, like data backup and storage. I think this story is one story of Web3, but the other story of Web3 is basically the Nillion one, which I think I'm like super excited about. So what is Nillion's approach to Web3? It's basically decentralized storage in the cloud, along with decentralized compute also in the cloud, on top of a very well-established cryptographic primitive, the one-time mask, and a mathematical formulation that allows for this storage and compute to work well together. So you can imagine all the benefits of Web3. Basically, you own your own data. You have control of the terms of which other people can use it. Of course, all the downfalls. You have to have more responsibility. It's like a little bit more harder and like more fraught with peril. But you get all the benefits of the cloud for backup and storage and distribution, everything like that. People in the know might say, well, wait a minute, this is just like blockchain just does the same thing. Well, I think blockchain and Nillion both are built, blockchain's a foundational technology. NMC is a foundational technology, which is what Nillion is building. For blockchains, there's a big consensus mechanism. These proof of work was the original one in the Satoshi white paper, but since there's been like proof of stake, proof of space, proof of all sorts of things, the silly idea I had when I started reading about this was proof of puzzle, which is like, oh, maybe we could have everybody solving the crossword puzzle daily as a way to mine blocks in like some sort of a ledger. I don't know. These types of distributed databases are great for immutable data, and they preserve ordering, so it's ideal for storing transactions between parties. This architecture is not ideal for computation. However, there's a lot of people that are using it as such. So Nillion and NMC is also a decentralized network, but instead of a consensus mechanism, we're cryptographically masking data on the user's computer before it even gets into the network. So we're basically, in a sense, even though this is not strictly true, putting the consensus first. The mathematics means we're allowing for collaborative computation between parties. That means running like arbitrary functions. Ordering is not preserved, so this is not ideal as a transactional ledger, but I think these two things working together could potentially just be magic. So I'm assuming, the front row has read the white paper. I'm wondering if many of you have read the white paper here. You should, it's actually really interesting. I'll give you my quick description of how NMC works. So the way this works is we have a decentralized network of nodes. Those are the ones in the middle. And you pull data from the decentralized, meaning that they're all owned by different people, or clusters of them are owned by groups of people. You pull data from those nodes. You use that data, this masking information, to mask your private data that's on your computer. And then you create particles, is the language we're using. And these particles can then be uploaded back into the network. Now, what's really interesting is, since you're pulling the masking information from a diverse array of nodes, in order for somebody to be able to access your data, they would need to take over, I think it is, at least 1/3 of the nodes in the network, which means that this particle that you've created is actually information theoretic secure, but it's completely portable because the security is based on the information that you use to mask the data, not the information itself, if that makes sense. But anyways, the key thing is these particles can go out onto the network, and due to the mathematical formulation, you can actually use those with other people that have used the same blinding factors to do shared computation with, and the mathematics is such that there's very little intra-node communication during that process. So in theory, it's faster than the next best commercially available thing, which is SMPC. Finally, after a computation's done, you get a result, and you can reconstruct that if you have sort of the original blinding factors. So this is really interesting. This decentralized storage and compute paradigm, what sort of opportunities does this create? Like I said, I think the marriage of like blockchain and NMC is going to be totally magic. So the Web3 use cases we're looking at, signing transactions, storing your cryptographic keys, supercharging blockchains, getting data in, out, and between blockchains is really interesting as well, like DAO stuff. So voting amongst like a bunch of parties who don't necessarily know who the others are. So like secret voting is something that we're talking about a lot. Past Web3, back to my passion, science and collaboration. I was talking to somebody about what it means to put a medical record, into a system like NMC, even your DNA, even personally identifiable information. So currently you can't do medical research on personally identifiable information because the people that own that are typically the people that are paying for your healthcare, which is like a reason why they would use that against you in a sense. But now imagine a world where we could do very detailed medical research using the full history of like somebody's life, but that life is stored in a very secure way. And so it's not an invasion of anybody's privacy whatsoever. As well, like Web 2.0 use cases, I think about like some of the trip data that we had for Uber that's very personal. There might be many opportunities for people to use this just as a general store for things that we want to remain private and not even accessible by the people who sort of gather it. How are we going to build it? All right, this is going to be it's a whole set of hard problems. So phase one, we're basically building right now, phase one. We want to recruit an amazing development team. We're going to set up our sandbox. We're going to set up testing protocols. We're going to set up development networks. We're going to set up all our processes. We're going to build the platform with very fixed functions, the NMC network. And we're going to put together a group of founding entrepreneurs that are going to build out some of our first use cases. We're thinking about 3 products right now in the Web3 space that I mentioned earlier. Once we sort of get the platform stood up and we have some initial product use cases, I think we're going to start looking at, scaling it out, building out smart contract and blockchain linkage because the DeFi space is so exciting right now, and I feel like there's so much opportunity there. Phase 3, we're going to build our own compiler, and we're going to allow people to define their own NMC operations. Then we're going to get into machine learning, science, all these other use cases, and we're going to leverage the possibility and creativity of like the general development public in what they can do. What do I think Nillion can be? It's all these things at the top, science research, DAO tools, machine learning, like this is all really, really, really cool stuff. It's exciting and we're gonna do our best. At worst, Miguel's pioneered a new way to cryptographically store data. These primitives are very interesting. This might be a whole new area of research. If we become somewhat successful, I think we have a very good shot at being like a glue layer that can connect lots of bits and pieces of like the DeFi world and put it all together in like a pretty amazing package. At best, if we deliver on our vision, we get this compiler out there, we scale the system out, we could be building an entirely new paradigm for cloud computing, which to me is really, really exciting. So now, engineering challenges, of which there are many. Specifically, our network stack is going to be very cryptographic in nature. We're using a lot of like secret sharing algorithms, verifiable sharing algorithms. How are these going to affect performance? How are they going to clog up the network, or will we actually be able to use them efficiently? We're going to be using tokens both for payments and for policing the network. And the policing of the network is based on latency, how fast computations are happening. There's going to be a whole bunch of variables here, but like logging those, if you can't do logging in a centralized way because it's a trustless network, this is a crazy problem for us to solve. What about the time delay effect between storage and compute? You store something in this network which requires data from the network at a given point in time, and then you want to recover it in 5 years. That's going to be an interesting problem to think about and to solve for sure. Distributed program composition. So for me, this is, at first NMC will be running very simple functions, but what happens in the future when people want to chain functions together, store intermediate results, how to do this more quickly? I think this will be really, really cool stuff to think about. Tokens for payment, staking, management. This is straight up blockchain and crypto, but I think this is really interesting that we're working on using these as a foundation for building something new versus working on these things themselves. Optimization. Optimization as a high performance computing guy has always been one of my favorite things to do, but optimizing a distributed system like this is going to be quite the challenge. But it's going to be cool, it's going to be fun, but it's going to be hard. Finally, we have a lot of math and a lot of, even just getting into how we're going to do basic authentication. I've realized working with Miguel, this is not so simple. It seems like almost everything that we're going to have to do, we're going to be working on new mathematical operations for the primitives we build, and that's going to feed into, the product development that we're working on. Another one I was just thinking about the other day that didn't get onto this slide is right now, if you think about using a seed phrase to regenerate your crypto keys, that makes total sense. For Web3, where the data sits on your computer. For the NMC model of Web3, imagine using seed phrases to generate a cluster of NMC nodes to generate your blinding factors. Beyond these specific challenges, I think distributed systems are already difficult. If you want to start a product, even on a mobile phone, you can do it with an application server and a database, and you can move really fast. We're going to need hundreds of nodes at launch time. We're going to need a lot of math to make this all work together. We're trying to do a little bit of everything. This decentralized, trustless architectures requires a completely new perspective on building these systems at scale. When you can't trust any single node in the network, all of a sudden it really limits the way that you can build things. But like I say, I love these kinds of problems because it requires a creative approach, and some of the brainstorming that we've been doing on these things, on these matters, has been really, really, really phenomenal. Finally, and this is where people watching this talk come in, we need to be good at so many different things to make this work. We need to be good at distributed systems, we need to be good at deployment, we need to be good at mathematics, we're going to have a product element. We basically, there's really interesting, compilers. We're going to have to be good at compilers eventually if we want to make this all work to our vision. I jokingly think it's we have so many different interesting, challenging, crazy problems in entrepreneurial computer science that we're basically like the Elden Ring of startups right now. Where do you come in? We're hiring. We're definitely working right now really hard to find the best possible people to form the foundation of our team. If you're interested in solving hard problems with me, definitely please, check out what jobs we have. This company might actually be the best place to learn about everything in computer science. So I'm really excited to hear from you. I'm really excited to be part of this project. And thank you very much for being here and listening to my story. Yeah.